Right, hello guys. All right. Before we jump in to solve the 11 questions and then the 12th question that I prepared, that I said to be the most difficult one, I would like to summarize some of the things and clarify some of the things before we dive into that. So first, remember we have annuity. And then we have perpetuity. Remember, annuity is when you make pay it's both of these are talking about payments, but one have a definite timeline, and the other one is infinite timelines, infinite payments, and then limited payment period. All right, one thing that I forgot to mention is on the annuity side, there's also something called deferred uh, annuity. And when we said deferred annuity, it's referring to a annuity that is delayed. And what I mean by that is, let's say you will receive $100 for 10 years. Well, let's just say for 2 years after 4 year period, right? So good practice here, 0, 1, 2, 3, 4. So after 4 years, you will begin to receive a payment of 100 for 2 years, right? So this type of problem where we have a delay of 4 years, and then you receive a payment that is called deferred annuity. However, I would say the most important is annuity dual, ordinary annuity, perpetuities, and growing perpetuity, which also called golden row growth. All right. Another clarification I want to make on the golden growth uh, formula before we solving questions is that all right, let me draw. So golden growth gonna grow forever, right? And let's say it is let's say usually the question it will give you like this, it's gonna give you a dividend today, and then it's gonna tell you the dividend gonna grow. Let's say the dividend gonna grow 5 5% forever from that point. So it's gonna be 105 for first year and then gonna continue to grow 5% forever. And let's pretend the discount rate, let's pretend the discount rate I is 10%. And so as you remember when we try to find the VO or the present value of this cash flow right here is equal to I would use the first one, DO, right? DO multiplied with 1 plus G, and that is 100 multiplied with 1 plus G. In this case, 5% is 0.05, and then divide by what I, right? The discount rate is 10% minus 5%, and that's how you have the VO, the present value. And the question is, okay, so let me try to compute this and see what value it is. Multiply with 1.05 divided by 1.05. So it is value at 2,100. So the present value, if you to receive $100 for every years or any period forever, and it's gonna increase 5% year over year, then the present value of that is 2,100, right? And the question is, where is this value? What is the present value of it? It is going to be right here, right? At time 0, it's going to be 2,100 at this point. Why is it important? Why do I stretch out this point? Let me blank page. Okay. Why do I stretch out that point? It's because I wanted you to see this different cash flows of Gordon Foreman. You will understand what I'm saying. Okay. Is because I'm gonna give you two other way. You're gonna see this type of problem, right? Okay, the first one is they're gonna tell you, well, I would say give me one moment. All right, so actually there's only, from what I remember, there only one other way that you could frame this. And this is the hardest problem that was mentioning to you guys. That called the two stages problem. Let me just reconfirm that I have a name correct. Okay, let's see. One second. Note. It's called two stages of growth model. All right. So something you're gonna see is that, well, actually there's two other ways. One way is the two stages growth model, right? It is, let's say, the dividend at time 0 is $10, and then it's gonna grow 10%, right? And then there's gonna be some value, and then it's gonna grow of 5%, and then it's gonna be some value, but then after that it's gonna grow only 2% forever, right? So this one is another way that you're gonna see the Gordon formula gonna play in which it is divided in two part. Where from period 2, in this case, I'm just using the year, right? In year 2, that is when they start to grow 2% forever, right? So if you use the Gordon formula, you know that let's just pretend at year 2, after it growing 5%. So first 10% it's gonna be to 11, and then 5% I just pretend it to $12, right? And then from $12 it's gonna be increasing 2% like that forever. Then using the Gordon model, if you use the D0 multiplied 1 plus G divided by I minus G, you have to know that the D0 is this 12 right here, right? So it's gonna be 12 multiplied 1 plus what is the G? 2%, right? What's the discount rate? I haven't give you guys, but just pretend the discount rate is 10%. Then what you do is 0.10 minus 0.2, right? So that's gonna give you a present value. And the question is, where is this present value lie on this cash flows? It's gonna be at year what? It's gonna be at year 2, right? It's gonna be at year 2. However, this is, well, remember this is also V0, right? Okay, so I would just use V0 as the present value at this year 2, just to make it less confused. Okay, why am I saying that? Because in the question, they want you to discount back to time 0, which is another present value. right? Don't go into deep into this one. This will be explained in the final at the very latest of these videos, but just wanted to keep in mind that when you're using this formula right here, it is mm, it is at the same times that you got at uh at the value that it hasn't experienced the 2% growth uh growth rate. Okay. All right, so that is one way. The other way it's gonna be is let's pretend that, so this is the hardest possible problem that could be there, very confusing. I do see that problem like this gonna be one question on the test. However, if it's not gonna be the end of everything if you don't get it. Okay, so the other thing is, like I said, defer revenue. I mean, well, not defer, I apologize. Um, well, let's say you're gonna be paid, so after there's gonna be the delay, right? If it's delayed 2 years and then after that you receive 100 forever. Uh, well, let me think. Let me think. 100. Well, you know what? Actually, okay. I don't want to confuse you guys longer, so just keep it one way. So one other way is the two-stage growth. Okay. One last thing I want to mention to you guys is um, when you're working with dividend, let's say if the question say that the dividend today is $100 and then it's gonna grow uh and then it's gonna grow to one, let's say 5%, um, and then it's gonna grow 10%, something like that. The dividend today, you don't really take into account when you find the present value of all the period. Okay. So 5% of 100 is 105 for period one. And then let's say 10% is 115, right? So you see, if you want, let's say if I ask you to find the present value of this, how do you do it? You have to discount the 105 back one period, right? And then you have to discount the 115 back to two period. Um two period. However, when you're working with the dividend, specifically only dividend, right? When the problem say dividend, some sort like that, the first dividend, you don't add it back to your calculation of present value. You will see this later on when I re-mention it. Don't go into deep about this. I just want to state it out there just so you bear in mind that it exists. All right. Okay, so we are ready to move on. Let me create a new page. All right, so let's go on to the first question we got. Okay, what is the effective yield on the loan which charge an APR of 6% and payments are made monthly? When it comes to this question, when I say effective yield, that is the key word there. APR, that is the key word. Here's the equation for the effective yield. Right here. Right? E1 plus EAR. So this one right here, EAR is the effective yield. So I just write out the equation first for you guys. Effective yield is EAR equal to what? 1 plus APR divided by M multiplied with M. So what is M? M is a number of period. What do you see in the question? The question say made monthly, right? So when it say made monthly, it means there's our 12 period. So you could already see that you will write it as 1 plus, I just plug in what it asks here, 6%, right? 6% is the APR. So 0.06 divided by 12, everything raised to 12, right? And that is equal to 1 plus EAR. Okay, how do you find EAR? You subtract 1 from both sides, right? And that's how you got EAR. So EAR equal to, so these two subtract, it's 0, right? 1 plus 0.06 divided by 12, raise everything to the 12 minus 1. Okay, I'm gonna put that real quick into the calculator just to see what it equal to. Y squared 12 minus 1. Okay, so the answer turned out to be 6.17. And let me double check the answer just to see if we got it. 6.17 is the answer. So one thing to notice is if this happens to say, if they say that quarterly, then you know that this should be divided by 4, this should be divided by 4. If it says semi-annually, it should be by 2, it should raise by 2, right? Yeah, so just keep it as simple like that. It's gonna happen on tests. I do see that there's gonna be at least one questions. And okay, move to the next one. Okay. How much would an analyst for Goldman Sachs recommend paying for 1,000 12% coupon bond that mature 20 years if the appropriate required rate is 11%? Okay. So one thing to not to notice is this one is talking about coupon, right? Some coupon. This is talking about bond. And one thing for you guys, this is the 1,000. So whenever they talking about bond, usually the 1,000 is they talking about the face value. And the face value, it just means that the ending. So just a brief explanation of for you guys what is a bond means. It means that the government, they probably require the government, they gonna borrow money from you with with the promise of paying you a some amount of money that called coupon payment, right? Of each depend on different type of coupon, but in this case, I just use the example of 1 year. They could pay for you semi-annually or quarterly, but in this case, I'm just using number of years just to make it simple. But at the end, they're at the last coupon payment, they're gonna pay you the coupon, right? But then they also pays you back the face value of 1,000 that they pay a 1,000 that they that you loan to them. So 1,000 is the future value on your calculator. Okay, keep that in mind. All right, so how much would an analyst paying for a 1,000 Okay. One thing to notice is this one is junk bond. From what I recall, the junk bond doesn't have the coupon payment, which is the payment that made for you. This one, it just means that at the end, they're just gonna pay you back 1,000 for 20 years, right? There's not gonna be payment in between. It's just at the end they're gonna pay you 1,000, right? And so the interest rate you have is 11%. So you see there's 3 items to look for, right? One thing, let me make sure I got this right. Okay, I make a mistake, you guys. Right here it's give you 12% coupon, right? Percent coupon. It's mean that it does have a payment in betweens. And it's gonna happen for 20 years. Okay. Let me organize this once again just to make sure everything is clear. Okay, so first, at the end, they're gonna pay you 1,000 for sure. So on the calculator, you put FE is 1,000. Number of period, 20 years, right? They didn't say semi-annually, quarterly, or anything like that. So number of period is just straight up 20. Okay. The interest rate, the discount rate, you see is 11%. 11%. And what is the payment? The payment each year, what should it be? Right here. When it say 12% coupon rate, it means that 12% of 1,000 is the payment each year. Okay, so what is the 12% of 12% of 1,000? 1,000 multiplied by 0.12 is 120. That is the payment, right? Each period. In this case, is each year. Gonna happen like that, right? Okay. Remember at the end, it's gonna be 120 add together too. However, in the calculator, you just put FE as 1,000. Because you put the PMT value is how much payment each year of 120, right? Cool. And then what are you looking for? You are finding present value. Okay, so this one is the 4, find 5th. 4th thing, and then find the 5th thing. So just input in your calculator, 1,000 for the future value, 20 for number period, 11 for the interest, the discount rate, 120 for the payment, compute present value. What do you guys got? I got 1,000, 1,017.13. Okay. I have a negative sign, right? But really, it doesn't really matter because you know that the present value is that. The negative, it just means that if you put the future value as negative, as positive, then the present value will show up at negative. The understanding of the number is that this number is present value is more important than the sign. Yes. Okay. So let's double check if this is correct. Okay. I have some minor mistake over here. All right. One thing to look out for, remember to clear your calculator whenever you do problem, right? Second, and then hit FV, which is the clear button. And then redo this to see if it's correct. Future value, 20 for a number period, 11 for the interest, 120 for 20 for the payment, compute present value. All right, if you do that again, I got 1079.63, and that should be right. Okay. So remember, I make a mistake there. Always remember to clear your calculator so often just to make sure that there's no error. All right, coming to question 3. How much is Betty willing to pay for investment that promise $80 per year? You see, pay 80 per year. That is some type of payment, right? So just begin trying out this to better understand perpetuity. What do you think? Perpetuity mean forever, right? If it pay forever, and you know the P payment, right? So the equation for perpetuity, once again, reflecting back to the equation sheet, is this equation right here. Down here is the golden formula, which is the growing perpetuity. But just make sure you know that this one is talking about D1. It's not D0, right? If it happens to be D0, it's going to be D0 multiplied with 1 plus G. Okay. So for regular perpetuity, just using payment divided by interest rate, right? So in this case, just $80 divided by what? 12%, which is 0.12. What do you guys got? 80 divided by 0.12 is 666.67. And let double check our answer here. All right, so we got it correct. That one is gonna be on the test, gonna be free and free question if you're able to do it. All right. What is the value of investment that promised to pay annual amount of 2,000, 3,000, 5,000, 7,000? All right, this is the type of problem that very useful for you to draw out the cash flows like this, right? It's not gonna grow forever. So pay annually, right? So first year, after first year's, it's gonna give you 2,000. After second year, 3,000, and then after third year, 5,000. After 4 years, it give you 7,000. Right? Why is this important? This is important is because first, you want to discount the 2,000 back how many year? 1 year, right? And then for the 3,000, how many year do you discounting back? 1, 2, 2, right? And therefore on the 5,000, 1, 2, 3, right? Because this is a present value. You want to find the present value of each of these payments and discount it back, right? So right here is going to be present value 1, present value 2, which is 3,000, present value 3 for the 5,000, and then lastly is 1, 2, 3, 4. The present value 4, which is 7,000, right? At the end, the total present value gonna be PV1 plus PV2 plus PV3 plus PV4, right? Okay, and that's what we're gonna do. Okay, so first PV1, let's do this together. PV1, right? 2000 is the value, is the future value. Number period is 1. Interest rate is what? Interest rate is 8%, right? So 3 thing, find the 4th thing, which is the present value. What do you guys got? What do you guys got? 2000 future value, 1 for the, well, remember to clear, right? Second clear. Always, I forgot to do that, and it's not good habit. 2000 for FV, 1 for the N, 8% for the okay. Remember, right? Here it's a annually, right? Annually, so these things is keep annually already. We will see problem that it says semi-annually right here. Semi-annually, and so you have to do something with these numbers. We will see it later on. Okay. Once again, I repeat, 2000 for a future value, 1 for the N, 8 for IY, compute present value. We got 1. We got what? We got 1.8, 1.851. No. 1,851.85. Okay. That is PV1. PV2, what are you guys gonna do? You guys gonna put well, 3,000, right? So it's gonna be 3,000 for future value. Once again, how many number period? We already draw out right here, right? 1, 2. So 2 number period. Interest rate 8. Well, let me clear my 3,000 future value 8 IY 2 for N compute present value. We got what? We got 2, 5, 7, 2, 0.02. And then for the present value for the third payment is 5,000. But 5,000 for the FV, 8 for the IY, 3 period, compute present value. This is 3969.16. Then the 4th one. Remember that these are all in N mode, which is the method that I'm using. 8 for IY, for the N. Last payment had 4 periods, so and so it is 5,145.21. Okay, adding these up, first one, second one, third one, fourth one together. Adding these present value together, you have the total present value. Yep, remember to change the sign from negative to positive and add them up. 3969.16 plus 2572.02 plus 851.85. Ooh, I hope I got this right. Let me see. All right, we got it. So the answer is 13,538.238. So rounding up into 0.24. Yep, so adding these yellow things I'm highlighted together, you should get that answer. This is gonna be on the test. Make sure you know how to do it. Okay, fifth one. Fifth one is let me see. If you plan to save 100 every 6 months for the next 5 years. Okay, interesting, right? 6 months, which means semi-annually, right? Okay. So for 5 years. 5 years, and it is semi-annually. So how many period is it? How many number of n? It's gonna be 5 multiplied by 2, right? This one is talking about semi-annually. So you know that you're gonna pay 2 times in a year, and it is 5 years. So it means that it is in total 10 payment in total, right? For the 5 years. For 5 years, there are gonna be 10 payment in total. Okay, so good observation right there, semi-annually. One more thing to keep in mind. Interest rate, discount rate, right? This one, 14%, which is the IY, right? Since this problem is semi-annually, you have to also divide by 2. Because this 14 is for a year, and you want to find what is the percentage for each period, which is half a year. So you divide 14 divided by 2 is 7%. So for each period, for each of the 10 period, it's going to be 7%. Let's say if it's happened to say quarterly, right? If it's quarterly, then you just multiply it by 4 and then divide this by 4. If it's say monthly, what do? Divide this by 12, multiply this by 12, right? Keep in mind. So those are the few things that gonna affect what you input in your in your calculator. All right. So you know it's gonna be 5 years. What is 100? 100 is a payment, right? So you know that is PMT. 100 PMT compounded semi-annually, how much it would be in the account for 5 years. So in this one, it doesn't give you the present value, so just don't care about it at this point, but it tell you to find the future value, right? Okay, how many things you have already? So you have 100, which is the PMT. You have the N, you have the IY. Then this is the 3 find fourth. 3 things find the fourth thing, which is the future value. That's what we're gonna do. Okay, so on the calculator, just clear it, second clear. 10 for number period, 7 for the IY, 100 for a payment, and then compute present. Oh, my apologize, make mistake right there. We should compute the future value. If it happens to say to find present value, you could also do that. You just input in and then hit find present value instead of future value, right? And 7 for the IY, 100 for the PMT, compute future value. Okay, so I got 1381.64. 1381.64, so that's the answer. Okay. Good practice for you guys is before the exam, just redo this on your own to see if you got it. If you got it, you got it. If you don't, then just make sure to practice a little bit more. I've been doing this for so many times now that I feel more confident. I'm also the same as you guys when I first seeing these problems. So, yep. What is the value of investment that promised to pay 4,000 per year for 10 years with the first payment 3 years from today? Okay. Okay, you see the first payment 3 years from today. So that it's have a delay a little bit, and then I'll just draw for you guys. 1 year, 2 years, 3 years. Okay. So it start to pay 4,000 in the third year, 3 years from today, right? And then it's gonna be happen like that for another 10 year. Right. It's gonna happen like that for 10 years. Right. So this is how when you approach these problems, how you solve it. If you use end mode, right? If you use end mode, begin mode, there's some trick you have to do, but in this case, I'll just explain using end mode. One thing you guys have to visualize is, let's say if I give you this problem, instead of defer one, if I say 4,000, 4,000, and like that for 10 years, you guys know that the present value is at this point, right? At this point, present value. When you compute the payment, the present value is right here. Okay, looking back at this cash flow, you have to see that when you use end mode, the present value is at year 2, right? Yeah, it is at year 2. Okay, keep that in mind, right? This present value right here is not the final present value. I would say the final FPV, final present value, is at time right here. So first, we have to find the present value at time 2 first. This is a two-part problem. Okay. How do you find it? You know, payment is 4,000, and then it's gonna happen for 10 years, right? So number of period is 10. Is 10. IY is what? 12%, right? Now what? You compute present value. What do you guys got? 4,000 for future. Well, my project. Second clear, 4,000 for payment. Number period is N. 12 for IY. Compute present value. That is 22,600.89, right? But remember, that is the present value at year 2. What do you have to discount this further? 1 year, 2 years, right? Okay, 2 years. Okay, so how do you do that? This present value, okay, with me here, second FE. Okay, hit this 22,600.89 become future value. Just do that. Just do that. It's gonna make sense. Make that future value, right? Okay. That's gonna become a future value. Since it is at year 2. Future value. All right, discount rate still 12%. IY is 12. How many period? 1, 2, right? So 2 for the N, and then compute what? Compute present value. What do you guys got? The final present value is 18,017.29, right? Let's double check. Okay, 18,017.29. Yes, this question will be on the test. Make sure you know how to do it. Yes, just redo the problem until you kind of like see how you wrap around it. Yes, but it's gonna be on test. Look at let's see, look at question 7. Oh, where is it? Okay. Okay, Justin borrow money to purchase an RV for 12,000 and repay. Okay, this one is interesting one. What do you guys see? Quarterly, right? So it should be suspicious of that. Quarterly payment, so it should have a payment. Uh, how much will be her quarterly payments? Okay, so they ask for the payment, right? Okay. So Justin borrow money to purchase of this amount. So something, what are you gonna do? You draw cash flow, right? Okay, the guy put down a negative of 120,000. I just put a negative, just mean it's cash outflow. And then you kind of see like, okay, what is the payment for the next 8 year, right? So 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's gonna be so you're trying to find the X amount. What is it gonna be for the X? Okay, so what do you know? What do you know? No, interest rate is 8, right? 8. Interest rate is 8, but quarterly, what do we do? Divide by 4, right? So interest rate for each period will be 2%. Uh, this number one here doesn't mean 1 year, right? In this sense, it is like a one of 4 quarter, right? So one period. Okay. 2%. How many number of n? 8 years, right? 8 years. But how many period in each year do you have to make a payment? 4 times each year you have to make a payment, right? So that makes it 8 times 40, 32 number of period you have to pay. All right, you know what? I make a mistake right here, right? I say 1, 2, 3, 4, 5, 6, 7, 8. That's that's so wrong. The reason is it's gonna be smaller than that. There's gonna be 1, 2, 3, 4, right? So it's gonna be X, 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 right? That make up 1 year. So 4 payment to make up 1 year. And then at the last one, this one is the 32nd payment. Okay, don't worry about that. I'm just trying to give extra information. But right here, you know two things. 2% and the 32 number period. What do you got? What is present value? Present value, you put down 120,000, right? Okay, so this is a 3 find fourth. You just need to find a payment. Okay. 2 IY 32 for number of period, 120,000 for the, well, make sure to clear your calculator first. I always forgot. 120,000 for the present value. IY for 2%, 32 for a number period, and then compute payments. All right. Yikes. Let's see if it's right. Okay, I got negative 113.27. The sign doesn't really matter. I'll keep it positive, but I understand that it's a payment. So this is the payment. Okay, let's double check. 5,113.27. So we got it. Right? We got it. Right here. Question B. Part B to this is what happened if she made the first payment from the beginning? What happened if she made a payment from the beginning? Let me think. Good. Okay. In this question will not be on the test, but just for the sake of answering you guys, there's two ways. One way is you're using begin mode. You just switch it to begin mode and then put this same data in. You will get what the value will be for the begin mode. I will do it now. So what you're gonna do is clear your calculator first, hit second PMT, second enter to change it to begin mode. Then just put in 2 for IY, 32 for the number period, 120,000 for the present value, and hit compute present value. I'm gonna give you 5,013.01, right? That is the answer right here. That's correct. One thing is this is a good experimental is because you see, this is something you could try to visualize. You have to kind of look at the cash flow, right? And you have to ask yourself, um, and you have to kind of observe how is it makes sense. The 5,013.01. How does it make sense? If I'm to explain further, it's gonna take a lot more time. But if you have enough times, just kind of think how this is gonna be on the cash flow. This is really important is because this is important to your understand of the last part where I'm talking about the two stages growth model, where the first part is gonna be irregular growth rate, and then later on it's gonna be growing consistently with the with the same rate forever, right? The first year could be 10%, second year could be 20%, but then third year and so forth forever is going to be 5%. Think about that. If you're using end mode, think about where, if you find the present value, where it's going to be light on, because later on you have to discount something back, right? You just kind of feel there's something you have to discount back. Yeah, but just keep that in mind. We will continue solving. At the end, I will explain further what I mean by what I just said. But just keep in mind that, yeah, there's some interactions that you could observe. Okay, so second way you could do this is this 5,113.27. You could make it into future value. Discount it back. Let me think. Let me discount it back. How many period we have to discount it back? One period, right? It's gonna be this small one piece right here. Right, so discount one period back. IY is still 2%. And just hit compute present value. Yep, let's try that. But in end mode, right? So first cleared it, change it back to end mode, and then put in 5113.27 for future value, 1 for the n, 2 for the IY, hit compute present value. Yes, you also got 5013.01. Right? Okay. So that's the way. This part I don't see it's gonna be on the test. However, it's good to know. All right, let's wrap up these questions. I will continue question 8 to 11, and then question 9. Well, is it question 8? Question 8 to 11, and then the last one through the last videos.